Thank you for joining this lesson. We're going to handle longitudes and latitudes. Number 14 of this paper, where we are told that A and B are points on the Earth's surface and on latitude 40 degrees north. The 2 points are on the longitude 50 degrees west and 130 degrees in the east, respectively. Calculate the distance from A to B along a parallel of latitude in kilometers. So what you should do first is to sketch these 2 places. We're having on the globe, this is a 0 prime meridian, this is a 0 equator. Then they are both lying on latitude 40 degrees in the west. So this is 40 in the north, that is. Then now if they are on the same latitude, we have A being 50 degrees in the west. So 50 degrees in the west. This is 50 degrees in the west. We will have A here. And 130 degrees in the east. So from here, 130 in the east, we're going to have point B. Then now we have to find the distance from A to B along a parallel of latitude in kilometers. So this distance in kilometers is usually given by theta out of 360 2 pi r cosine of the latitude where the 2 places are lying. Therefore now theta is the angle difference from 50 degrees in the west to 130 degrees in the east. We have an angle difference of 180. So out of 360 times 2 times a pi of 22 out of 7 times 6370 cosine of, they are on latitude 40. Cosine of latitude, so latitude 40 degrees in the north. So when we compute this, we're going to have 120 times 2 times 22 times 6370 cosine of 40. Then this is divided by 360 by 7. So this will give us 15,336.21 kilometers. So that is the distance along the parallel of latitude. In part B, we're getting the shortest distance from A to B along a great circle in kilometers. So along a great circle, we're going to move. Remember, this is 0 degrees in the equator. This is 40 degrees in the north. Therefore now we're going to move from A, which is 50 in the west, and on reaching the pole, we go down through the same path. So when we're moving from 50 degrees in the west, and we continue with the same path now, on the other side we will be flowing through 130 degrees in the east. Therefore, this now becomes a great circle path. So the path here along the poles here, along the north pole, for instance, is going to be a great circle. So it's a great circle whereby we need to identify the angle at the center. And now we should remember that from 0 to this latitude we have 40, and from 0 to this other latitude we also have 40. Therefore, because along this straight line we're supposed to have 180 degrees, then we will have 100 degrees as the angle theta. Then we use the radius of the earth to get this arc, which is a great circle. Therefore we're going to have distance being given by theta over 360 2 pi r. So we're going to have a theta of 100 out of 360 multiplied by 2, then a pi of 22 over 7 multiplied by a radius of 6370 kilometers. So computing this in the calc, we're going to have 100 by 2 by 22 by 6370, then we divide by 360 by 7. So this is going to give us 11,122.22 kilometers as the distance along the great circle.